What can you do with these two equations, y equals h and x equals r? Well, I'll tell you. I'm Mr. Ish. Thank you for joining me. You can actually do your very first integral calculus application using both of these equations of lines. Think of h and r as constants. Think of them also in this way. Y equals h. I'm drawing some line. Y equals h. Here h can represent height. X equals r, a vertical line where r can represent a radius. Look at the region between this set of curves. Y equals h, x equals r. Your x-axis, your y-axis, here's the origin. You can set an integral. What's my function over here? Well, this right here is the function. Vertical lines are not functions. They fail the vertical line test, but horizontal lines are. My function here is h, y equals h. With respect to dx, I'm integrating. From here is 0 up to an r. Look what happens. I can bring this h out because it's really a constant. When you look at this item here, this tells you what your variable is, and your variable here is the x. Bring it out. Your integral becomes 0 to r dx. When you do the antiderivative of this, you're really looking here at an imaginary x to the power of 0 because it's equal to 1. And you know the polynomial template for integrals is n plus 1 divided by n plus 1. Here n is equal to 0. We'll have h, x to the 0 plus 1 divided by 0 plus 1. Upper limit r and a lower limit 0. What do we get? h, x, r and a 0. And what we get over here is an hr. What's the significance of hr? Well, it could have been any letter, but here I'm purposely using hr for a purpose which will come next. It represents right over here a height or a length, and right over here a width, which here we're just calling r. You've actually here derived the formula for a rectangle. This right here is rectangle. You know here's h and r, or you can say length times width. Again, you could have used l's and w's. Y is equal to L, x is equal to w. I purposely use h and r for the next example where this feeds into. Anyhow, we've derived the equation here or verified the equation of a rectangle. Again, the same representation. Application number 2. You have this region of space. We know this area right here is equal to hr. If you were to take this region of space, which is exactly what you see, and you rotate it around the y-axis, what do you think you'll get? You're taking this region of space and rotating it around the y-axis, you'll get what will be a cylinder, and you know it. What you're seeing right over here, this part right over here would have been this region of space, which I have shown over here, and it revolved around or rotated on the y-axis, and it gave you a complete cylinder. This is exactly why I used h and r, because cylinders have a height, cylinders have a radius. Here's my radius, and you know it, and here's my height. Hence the h and the r that I used from the very beginning. If you were to take the cylinder and take a slice out of it, what are you going to look at as a cross section? It'll always be a circle. What's the area of a circle? It's always pi r square. If I'm looking here at this circular cross-sectional slice, what's the radius of the slice? Well, the radius is right here. We know radius here is equal to r. What's the area of this cross-sectional slice? Well, it's pi r square. If I were to take this area, these cross-sectional slices and their areas, and integrate them from a lower limit 0 up to upper limit h, we'll have the cumulative effect of all of these circular areas, the slices, and we'll get our volume. We will have a pi r square integrating from a lower limit 0 up to the height of this cylinder, and we're looking here in the y-axis direction. Here is our integral with respect to dy. What's my variable? It's not pi, it's not r, it's not h, it's y. Y is my variable. All of this can get pushed outside. Our integrand is pi r square from 0 to h dy. Here you have an imaginary or hidden y to the power 0 because it's equal to 1. Run it again here through this template. You'll have pi r square and then 0 plus 1 over 0 plus 1. You have h and a 0. Pi r square, you have a y, upper limit h and a 0. You put upper limit, lower limit, and always the difference of the two. You'll have pi r squared h. What's pi r squared h? It's the volume. Volume of a cylinder is pi r squared h. I've shown you here how you can verify or derive the equation of a rectangle. Again, you can do L and W or H and R, and I've shown you the volume of a cylinder pi r squared h. Derived it for you here using basic integral calculus application. Have a good day.